let me move over to Descartes and ask you, first of all, this question: outside of this reading assignment, does the name Descartes ring a bell at all? Is it a name that's familiar? In what connection? Yeah. In math. In math. In particular, anything?
His system.
His system of what?
Cartesian graphics.
Cartesian graphics or Cartesian coordinates.
Yeah.
Does everyone know what Cartesian coordinates are? That's this. The XY axis. Now, Descartes was indeed a mathematician, probably one of the greatest mathematicians ever lived. If it weren't for Descartes, all kinds of things wouldn't have happened, at least at the time they happened. I think probably it's safe to say that Isaac Newton and Gottfried Leibniz would not have invented the calculus some 50, 60, 70 years later if it weren't for the prior development of analytic geometry. And it's in the development of analytic geometry that this coordinate system comes up. So first let me write down Descartes. Is the deviser of analytic geometry. Now, what's analytic geometry? Simple. Let's just note that the word analysis is sometimes, historically and even more recently, is sometimes used to, as another term for what is more popularly known as algebra. Okay? And so what analytic geometry does is it allows us to express the truths of geometry in algebraic form and the truths of algebra in geometric form. What does that mean? Well, here is an algebraic formula to keep it simple. Right? That's algebraic notation, y equals x. You get more complicated ones that we'll perhaps get to later. That's a simple one, but what the coordinate system in particular allows me to do is to express that in a picture or geometric form by using a line. Now that's geometry that you see before you. Okay? And that just is the equation y equals x. But also before, when I asked you what is the Pythagorean theorem, we talked about that in connection with Plato. I asked what's the Pythagorean theorem, and anybody who knew it gave me the algebraic version of it, namely c squared equals a squared plus b squared. Now our ability to express the Pythagorean theorem in this way is due to Descartes, due to analytic geometry. Flip that. The old way of expressing it, there's the right angle. I'm not very good at keeping these things the way they should be. Okay. The old way was to just draw and point this square, the square on the hypotenuse, as equal to the sum of these two squares, the squares on the other two sides. What do I mean by summing those things up? Well, the area of this square is equal to the area of this square plus the area of this square. And the way to prove that back in the time of the Greeks was by construction, by doing the kinds of flipping, imaginative flipping of figures that you see going on in the Meno as Socrates talks to the slave boy. And that's the way that geometric proofs were executed, through geometric construction. All right, and as anyone can see, since the side of this square is C, and the side of this square is A, and the side of this square is B, you can immediately see that to say that the area of this square is equal to the area of that one plus the area of this is just to say C squared equals A squared plus B squared, right? All right. Simple little excursion into math. Descartes' contribution, insofar as, he's the guy that invented this thing that everybody knows. This isn't some esoteric, far out mathematician who made a contribution that no one ever heard of. I mean, this kind of contribution everybody knows about. This is not only useful in theoretical mathematics, but it's useful in applied mathematics. It's the kind of thing that people actually use in normal human lives, not just theoretical mathematicians. So Descartes' contribution is quite remarkable, opening up an entirely new area of mathematics and opening up an entirely new area of not only mathematical but practical possibilities. So he's a great mathematician and was well known as a great mathematician in his own day. What's more, he was also known as probably the foremost physicist of his day, or natural philosopher as they were called then. At least a theoretical natural philosopher, because of his own work in that field. He was arguing, as we will see, for mathematical treatments of the sciences, along with some others, like Galileo. But his own approach to physics and his own theories in physics were probably the most important in the 17th century up until Isaac Newton. So he was extremely well-known, extremely well-regarded all over Europe, both as a mathematician and as a physicist. Nonetheless, he's best known in modern times, best known, at least popularly, for the work that you just read, for the Meditations, the philosophical stuff. And what's more, that's the way he thought about it at the time too. He'd done a good part of this work in math anyway, and he'd done a good deal of the work in physics that he was then and would later be renowned for. But when he sat down to do the Meditations, he took it that this was going to be one of the most important things he'd ever done. And that's, as I mentioned a moment ago, that's the way history regards him. So that should be a bit puzzling. I mean, at least at the outset, that should be a puzzle. Here's a guy who's made these kinds of contributions, and yet he's best known for the thing that you just read. Why? What's in there? So that's the first question. What do you see going on in there? One thing that plainly you see going on, although you might not recognize it as such because you don't maybe know the Latin, but what else is, I mean, is Descartes famous for any other thing apart from his mathematics prior to your reading him just now? Yeah, okay. Cogito, ergo sum, which he never actually said in the Meditations themselves, but this is the Latin expression that's supposed to summarize one important argument there, and the English for that is usually translated like this. Now, did you see something? You did notice in your reading that he did try to prove his own existence. Now, there's a contribution. Descartes proved his own existence. Must have been relieved. Well, what's going on in there? What is his objective? He proves his own existence after doubting the evidence of his senses, doubting this, doubting that, talking about some evil genius. I'm just going to read from the first part of Meditation 1. After he's got all this other stuff, he's offering prefaces and synopses and all that stuff, but when he gets to the beginning of Meditation 1 itself, he says this: "Several years have now passed since I first realized how numerous were the false opinions that in my youth I had taken to be true, and thus how doubtful were all those that I had subsequently built upon them." That's clear enough, right? before I go any further, this is written 1630s, I think, somewhere in there. What's been going on in science? Do you know that? I mean, I'm going to have to tell you a little bit about that background. But I'll give you more in a second or two, but just to help you. I mean, Newton comes some 40 years later, 30, 40 years later, his work. But just prior, in the first 3 decades of the 17th century, Galileo has turned lenses to the sky. He's able to see the planets more clearly. He discovers moons orbiting around Jupiter. He looks at the face of the moon. It looks like, to him anyway, it looks like it's got mountains on it and craters. It doesn't look like some kind of an ethereal object. It looks like a big chunk of normal, Earth type stuff. Galileo's also figured out the equations for motion. I don't know exactly about the dates on Kepler. Kepler is beginning to figure out how to describe the motions of the planets more accurately. More and more people are embracing the Copernican view. We'll come back to that in a second. But this is a time in history that's often thought of as the birth of modern science. Okay, so people who had been trained in the schools when Descartes had been trained. I mean, Descartes also making, as I mentioned, making contributions to this, the scientific change. But people who had been trained in the old way are suddenly faced with the fact that, boy, all that stuff that we learned in the schools, it's not right. I mean, if we take this new modern scientific approach, we learn that things are a lot different from what we've been taught. So when Descartes says this, that several years have now passed since I first realized how numerous were the false opinions that in my youth I'd taken to be true, and thus how doubtful were all those that I had subsequently built upon them, he's talking about that. He's talking about changes in the picture of the world that had been embraced by people just a few decades before and what was emerging now. The changes were remarkable, huge. Now, we tend to think of the 20th century as a time of radical and fast scientific change. It is, but especially here in the 90s, we're used to it. I mean, in the first 3 decades in the 17th century, it had been centuries of slow progress in the sciences, and now suddenly a good quickening of the pace. So this was quite shocking. But so he's realized that, boy, now I see that lots of the things that I was taught, lots of the things I believed, they're not right. But what's the new standard? I mean, he goes on. Thus, I realized that once in my life, I had to raise everything to the ground. I had to just eliminate all the beliefs, and begin again from the original foundations. And here comes the kicker. If I wanted to establish anything firm and lasting in the sciences. I mean, this is for the purposes of building the sciences. He is at a time and in a place where people are trying to figure out how to proceed with science. We're abandoning lots of the old beliefs. We've got all kinds of new data. We're learning all kinds of new things. We're building all kinds of new theories. How are we going to place foundations under those? I mean, we want science to be more secure than it used to be. We want it to be more trustworthy. Now, how can we do that? And so Descartes proposes that what he's got to do is to tear down all of his beliefs, even the new ones that he's got, start building from the foundations, if science is to have secure foundations. So his project is to try and figure out how to provide science with any kind of a firm and lasting foundation. Okay? So this is a science-oriented project. He wants to somehow, and this is the beginning of a bunch of things that should remind you of Plato. I mean, Plato wanted to focus attention on those things that are provable. Let's not worry about the things that everybody argues about. That's just beliefs. Let's figure out if we can find some sort of foundation for knowledge, and by that he meant for stuff that's provable. So similar motivation in a different time. Copernicus, does that name ring a bell? I mentioned, I think, the Copernican worldview or something a few minutes ago, but who's Copernicus? He's dear to my heart because he's a fellow Pole. But apart from hailing from the same country that Sanders' ancestors hailed from, what's Copernicus famous for? Interesting. Somebody knows.
Is he the one that said that the sun revolves around the sun rather than the way around?
Yeah, exactly. For 1,500 years anyway, the most widely held view about how the solar system works, indeed about how the universe works, suggested that the Earth was at the center. Okay? Then, of course, the moon goes around the Earth. Moon. But then also, the sun goes around the Earth. That was the scientific view for 1,500 years before Copernicus. Now, it wasn't always the scientific view. I mean, there's different views possible, but this was due to some remarkable work by an astronomer, I think just after the era of Christ, named Ptolemy. And so this particular picture of the universe, I mean, the stars are supposed to be doing this too, okay? There's a sphere of fixed stars out there. Not fixed, but fixed stars. And that's going around too. And everything's rotating around the Earth. It's just the way it looks, okay? And then how to get those rotations just right so that they meet, so that they fit with observations. Well, this was the main work of astronomy for 1,500 years, and it was brilliant. I mean, they figured out all kinds of amazing things to explain the observed motions of the planets and the stars and the moon and the sun so that it would fit into this particular theory. It's quite elegant. Think of an example. For example, I mean, this is really rough because I'm not an observational astronomer myself, but here's Earth. Some of those planets outside the orbit of Earth. Let's start with the ones that are inside, okay? Some of the planets that are inside of the orbit of Earth are easily observable. Venus, for one, is an easily observable planet. But because it's inside our orbit, and especially this would be true of Mercury, and I don't know whether Mercury had been tracked and observed before Copernicus or not, but let's just take Venus as an example. There's the sun again. Looks bemused. But there's the sun again. In observations of the orbit of Mercury, it stays pretty close to the sun. And it always stays inside our orbit, right? It always seems to be on the sun side of us. Now we know, given the picture that we are likely to conjure up of the sun being at the center of the solar system, we know why that is, because our way of putting it is that Venus is on an orbit that's closer to the sun than our orbit. Of course, they couldn't talk like that because that's not the way they looked at these things. I mean, the Earth is standing still and all the other stuff is orbiting around the Earth. But the observational facts are still there. The planet Venus stays closer to the sun all the time. And furthermore, it's always sunward of us, okay? Indeed, Venus is what they call both the morning star and the evening star. It's the last star in the morning because it's close to the sun and it's getting reflected light. And it's the first star to be seen usually at night for the same reason. I mean, it pops up over horizon, if it's in the right position with respect to the sun, it'll be the first glowing thing that you'll see in the sky. All right, well, how do they resolve that? Well, they said, well, Venus goes around the Earth all right, but it also goes around the sun. It has a motion like that. See, and as the sun goes around the Earth, Venus goes around the sun, and that's how they resolve that problem. Another problem with the outer planets, just to give you some examples, well, this is not so intuitive. This is bad enough. But the outer planets sometimes do the following thing. Because we're tracking an orbit that's inside of theirs, and because we pass them sometimes, this is now on the view that we are likely to entertain. You could describe it like that. The following thing happens to the observation of the outer planets. Jupiter, say, which is quite visible in the sky. If you track it over a period of days at the right time in the two orbits, sometimes the path of one of these outer planets will look like this in the night sky. It'll go up to there. And then as we pass them and pass that planet in its orbit, it goes back that way, and then it goes like this and continues. Now this is a phenomenon that we would now say results from the differing speeds and differing paths that our two orbits take as they go around the sun. But they didn't have that available. They still had the same observational facts, so what they said was what's sort of obvious, is that what happens to the planet at that particular moment is it's going around the Earth all right, but right there it does this kind of thing, okay? And we see this flat on, so it just looks like that. But really what it's doing is it's making a big loop up there in the heavens. But these are quite ingenious, and they had, these are called cycles and epicycles, I think. And then you can have epicycles. And there's a very elaborate geometric, notice, a geometric theory of the heavens, that because it's something that's done with usually perfect circles and circles within circles and other things like that. And that's the way the theory evolved over 1,500 years up until Copernicus' time. Now, Copernicus is writing in the 16th century, somewhere in 1550s or 1560s or something like that. You can look that up. He offered a simplification. He said, look, maybe it's not like that at all. Maybe the sun is in the middle, and the Earth, and all the other planets are orbiting the sun. And now this wasn't too different from the old system in this respect. The sun was still conceived to be the center of the entire universe, so the stars are still going around it. But it was a very dramatic move anyway. A very dramatic move from going from suggesting that the Earth was at the center of the entire universe to suggesting, on the other hand, no, it looks like it's the sun. Now, this was to have serious theological implications at a time when the Church, the Roman Catholic Church, was very influential in Europe, very strong in Europe. Why might there be theological, religious, that is, religious problems with accepting this theory? Anybody? The Church favored the old Ptolemaic view. Okay, this one is called the Ptolemaic or geocentric theory, where geo refers to Earth. This one is the heliocentric, or Copernican, after Copernicus. Why might there have been religious objections to this theory?
Nobody would trust the other stuff it says on the Bible?
It doesn't say anything at all about this in the Bible, about what goes around what.
Like the church says the geocentric theory.
The church did adopt and favored the geocentric theory. They liked this one, Earth at the center. Everything else goes around the Earth. But it's not because it says that this is true in the Bible, as far as I know. Does anyone know different? I don't think it says anything about this at all in the Bible. I don't think the Bible really dwells very much on astronomical subjects. But there is a clear reason, based on stuff that it does say in the Bible, for favoring the geocentric view. What?
They would be thinking, why wouldn't God put him in the center of the universe?
Yeah. Somebody else elaborate on that. How about you?
Well, wasn't it concentric means like the center of, like, ethocentric? So wouldn't they think because they're God's most important creation, they should, you know what I mean?
Exactly right. What was that? What you were going to say?
He made us in the image of his head.
Right. We are made in God's image. I mean, we are God's most important creation, right? I mean, humanity. So of course, and I think this is what you have in mind too, of course God would place this in the center of his creation. He would place humanity and humanity's home in the center of creation. Indeed, the suggestion in the Bible is that everything else was pretty much built, the entire universe is pretty much built for mankind's use and pleasure. So that's the theological reason for favoring this theory. But it didn't crop up immediately. Okay, the first thing that happened was Copernicus died pretty much immediately after writing the book in which he recommended his theory. Okay? And the book had to be published with a preface written by somebody else. The preface said this. Oh, here's an interesting, this is basically what the preface said. Here's an interesting mathematical theory. It's not to be taken seriously as a theory about how the universe really is, but here is as an elegant mathematical trick offered by Copernicus that will help us perform the calculations on the movements of the heavenly bodies more easily. In other words, to treat the sun as if it were in the center simplifies things. So let's just pretend that for our mathematical purposes, even though we know damn well that, of course, the Earth is at the center. That's the tenor of the preface. Now, I don't know whether this was done cynically or not. It's very likely, just as possible that the person did this because he really believed that the Earth was at the center, and he really believed that this was only a mathematical trick. That's possible. But it's also possible that the person did it more cynically, thinking, well, we're never going to get this by unless we put it like this, so we better put it like this. But the first reaction of the Catholic Church was to say, oh, well, that's not a problem. Those mathematicians. As a matter of fact, most mathematicians and people were being trained in universities that were run by the Catholic Church. So part of the problem is getting your textbooks accepted in the only schools around, which were Catholic schools. So they accepted the texts at first and didn't have any problem with this until people began to seem like they were taking the theory seriously as a physical theory rather than just as a mathematical trick. I think it must have been around 1590 that a writer named Giordano Bruno began to think about this heliocentric theory. Okay? This new theory of Copernicus's, and he said, that makes sense to me. And he was taking it very seriously. He was certainly not treating this as any kind of a mathematical tool at all. He says, I think he thought, this works so elegantly in sort of helping us to avoid all these circles and epicircles. It must be true. It must be right. So he began thinking about that, and he began to be dubious about the one thing that I mentioned. He began to wonder about the supposed sphere of fixed stars that was itself supposed to be, on the Copernican system, orbiting way out there. Okay, I'll just complete the circle here. You got to wonder about that. And he developed the following theory. He said, I'll bet this isn't correct. There's no particularly good reason to really imagine that there's a limit to space. I mean, what's on the other side, after all? That doesn't make any sense. Why should space suddenly stop out here at the limit of the fixed stars? And then what? What's on the other side? That doesn't make any sense. Much more reasonable, he said, is to imagine that space is infinite. Bruno loved the whole idea of infinity. He just was dwelling on this idea, thinking about infinity. He said, what if the universe is actually infinite in its scope? And there is no sphere of fixed stars. In fact, what if those stars that we see are nothing other than suns like our very own? Very intriguing hypothesis. And boy, if that's right, and if space is limitless, and the stars go on, maybe there's limitless numbers of these stars. There's no reason, this was his argument, his basic argument was, there's no reason to imagine such a limit. I have no evidence, no reason to postulate that there's a limit to this. So he thought that space was unlimited and that there were an unlimited number of these stars, and each of those stars were suns. And he went on. He said, and there's no reason to suspect that those stars don't have planets just like ours does. And there's no reason, he finally added, to suspect that those stars don't have people on them or beings like ourselves. There could be infinite planets with infinite civilizations going on forever in every direction in the universe. Big hypothesis for 1590. And he made the mistake of making this suggestion at least public enough so that the Catholic Church got wind of it. Well, the Catholic Church, when it heard about it, sent him a little note. Now, this is the era also of the Spanish Inquisition, when people's souls were being saved by burning them at the stake. And people who did not believe the right things were being saved in that way. They sent him a little letter. I don't know if it was the Spanish Inquisition or whether it was from the Vatican, but they said, hey, Giordano, just read your latest book. We'd love to speak with you at your leisure. Well, Bruno realized that he was in some trouble, and so he sort of split, left town, hid out, but was finally tracked down something like 9 years later in 1599. He was interrogated, and his soul was then saved. He was burned at the stake in 1599, in part, anyway, for these heretical beliefs concerning the structure of the universe, probably for some other things as well, some other problems he had with the church. But he was burned at the stake in 1599. Now, keeping that in mind, there's a few more things to tell about this story. Anybody who was doing science, especially anybody who was in basic sympathy with the Copernican theory, had to sit up and take notice about the fate of Giordano Bruno. The other thing I wanted to tell you was that Galileo himself, who in the early, I think it's in fact in the very first decade of the 17th century, someplace between 1600 and 1610, had been the first to design a working telescope, as far as I know. And he pointed that telescope to the heavens, detected things like at least the first 4 moons of Jupiter. He could see that indeed there were moons orbiting Jupiter. He could see the surface of the moon, and at least as far as he was concerned, it sure looked like dirt and mountains and things like that. So he was certainly a partisan of the Copernican view. He appears to have not published much on this subject until we get up till around 1632. In 1632, Galileo decides to bring his book to print, a dialogue concerning the 2 chief world systems. And what his idea was is simple. His hope was to kind of diffuse this debate. He didn't like the idea that scientific research was getting objected to by the church. Now, I want you to understand that Galileo, as far as I know, was a very devout Christian. He was Italian. He had close friends and colleagues in the church. He was very involved in the church. but it just struck him as being wrong that the church should object to the Copernican worldview. So he thought he would write a kind of a dialogue, like Plato's dialogues, like those that we saw before, wherein two different people would argue the merits of the two different astronomical systems. And then the upshot of this would be that the Copernican system would come out victorious. I mean, he would try to show the reasons why the Copernican system was better, but he was going to pay all due respect to the older Ptolemean or geocentric system as well. So that's what he did. He produced a book in which people were arguing about the two world systems, and he thought this would be a good way of, so paving the way for greater acceptance of this view, within the church hierarchy. But when the book was sent to press, he got a message. It wasn't a phone call, of course, but he got a message from the church saying, Galileo, we just caught wind of that new book of yours, and it seems that you're endorsing the Copernican system. And as you know, we have a special interest in that. Wonder if you'd like to come down to the office and talk this over. Now, Galileo, as I say, he had friends in high places in the church. He was sure that they were reasonable and rational people, and so he thought, yes, I'll go down and talk this over, even though Bruno's fate must have been, vivid in his own mind. So he went to the meeting and fully convinced that he could convince them of the wisdom of going ahead with the publication. He sat down and talked to them. And then the upshot of that meeting was not that he was burned at the stake, but he was required to recant his view publicly and say that it was a mistake, to withdraw his book from publication, and he was placed under house arrest for the rest of his life. Now, the reason all of this is relevant to Descartes is because Descartes himself had a book called Le Monde, which could be translated the world, but what it was about the cosmos, and he had been just ready to bring it to publication as well. In fact, I believe he'd sent off a copy to be reviewed by somebody in the Catholic University in Paris, asking, can this book be used as a text? Because that's the way you got your book to get read, is by making it into a text at the university. And in this book, Descartes too endorsed the Copernican system. And it was just at this time, right in 1632, Descartes heard what had happened in the case of Galileo, so he quickly withdrew his request that his book be accepted at the university. He didn't want to have to go through the same thing himself. But the point is that, he was very personally involved in this whole affair. 1632 isn't that far away from 1599 when Bruno was executed. It seems that the church still was taking this very seriously as a heresy. And Descartes was just beside himself. He too was a very religious person, as you can see, I think, in some of the things that are written in the Meditations. He's someone whose belief in God is extraordinarily strong, and his belief in most Catholic theology, I think, was pretty unshakable as well. But here was a place where the Catholic Church seemed to be taking an interest in scientific matters that Descartes did not think really were appropriate. And he felt, I guess the way to put this is, he felt that science really couldn't threaten theology. That science was just trying to figure out how the magnificent creation of God worked. No challenge to the idea that God created it, no challenge to the sort of the things that were really central to theology. So in the Meditations, there are kind of two chores that he undertook. One was to sort of establish exactly what the correct foundations of science were. This is kind of a forward-looking project, a project that involves trying to clarify what the difference between science and non-science is, so that, as he says in the first few lines of the first meditation, so that we can know which of our beliefs we can rely upon and which ones we can't, at least as regards science. He has no interest in doubting his own existence, for example, or doubting the evidence of his senses, not for normal day-to-day purposes. That's not the point. His point is to say, can we rely on the evidence of the senses, or can we rely on our former beliefs when it comes to doing science? So project number one, the one we mentioned before, is to try and clarify just exactly which beliefs can be with certainty relied upon and therefore used as the foundations or the basis of science. So that's one thing. But the other thing, the other project here, and I won't dwell on this too much more, is to try to establish for the church the idea that the inquiries of science do not threaten theology in any way. That the realm of the material in particular, which is what science studies, is completely independent from the realm of the soul, the realm of the mental, which is more the realm that theology is concerned with. And so what we get out of, and again, we're not going to have time to dwell on this particular aspect. It's a very important aspect of Descartes' philosophy. But he established a dualism between the realm of the mind or the spirit on the one hand and the realm of the body or the physical on the other. And while he wasn't the first to do this, to suggest that a human being is a combination of two entirely different substances, the mental and the material, he wasn't the first to do this. Nonetheless, his way of presenting this idea and arguing for it became extraordinarily influential in lots of subsequent thought, both in philosophy, of course, but also in the sciences themselves. But what I want to get to, though, is his use of a certain peculiar method in trying to establish which things we can be certain of. And that's what you have before you, especially in the meditations up to about the third meditation. That's what I want to focus attention on right now. Now, what's going on in there? I mean, we see him doubting lots of stuff. I mean, he starts off saying there's lots of my beliefs that I'm not sure of, but then he proceeds to doubt everything. Why is he doing that? Suggestions? He even goes so far as to suggest, this is kind of peculiar, that there might be an evil genius, that the way he portrays this evil genius, it seems like this evil genius might have the powers of a god almost. He thinks there might be some evil genius whose evil project is to just fool Descartes about every single thing that he might have faith in. What's the point of all that? What's the point of all this doubt, and then even going to the extreme of imagining an evil genius? Any suggestions? Or was that just a mystery?
It seemed almost like he was trying to sort of make it so that the church wouldn't get too mad at him.
How? What are you thinking of in that light?
He was bringing up the possibility that he could be wrong. He wasn't saying, "Oh, I'm right," and the church is going to get mad at me. It seemed to me like he was saying,
I think there is some of that. There is some of that in there, but that isn't the main purpose, I think, of what I'll now call the method of doubt, the method of metaphysical doubt. This is a method that's supposed to achieve a certain end. And maybe it's that it's too obvious for you to think it's the right answer to the question. But is there anyone, what's the point of doubting all these things, doubting the evidence of the senses? Remember what his project is. He wants to find out if there's anything at all that he can be absolutely certain of. Why does he talk about the possibility that he's hallucinating? Why does he talk about that evil genius? Yeah.
He's trying to start off not being sure about anything.
He's trying to start off being unsure about it. He's trying to start off being unsure about everything.
Everything that he's learned and taught, or people have told him that he's come to believe, he's trying to...
Okay, I'm beginning to think maybe it is. It's so straightforward and obvious that this rhetorical question of mine is sort of falling on. I mean, you're trying to look for a deep. Yes, that's exactly right. He is trying to doubt everything, but why is he trying to doubt everything if his project is to find out whether there's anything he can be absolutely certain of? I mean, on the one hand, that might sound like that there's a little conflict there, right? And I'm trying to see what, in a sense, it's sort of transparent. It's not tough, but in another sense, I would just want to make sure that, see, I don't know what's transparent in your first reading of this, since I've been through this text a lot, so I'm not really sure what's obvious and what's not, but yes.
The only thing he knows is that he doesn't know anything? Is
That sounds like Socrates.
Right.
That's not correct. He's trying to take a step beyond that, I believe. But he's, at least at first, it's seen he's open to the possibility that maybe he knows nothing. He is at least investigating this possibility by seeing if there's anything he can be absolutely certain of. The invocation of that evil genius is just a device that demonstrates that even some of the things that he's most certain of, well, he might be wrong about those too. I mean, the reason he considers the evil genius is to just demonstrate that the evidence of the senses, for example, is not reliable. Now, the evil genius might sort of not be very, it might not move your intellectual juices quite as much as other ways of putting it, but it doesn't have to be like an evil god or an evil genius. I want you to think about how it is that, in fact, we do get information. I mean, we hear things, we read things, we have experiences ourselves, right? I mean, that's how we learn about the world, starting from day -1 maybe, but at least starting from day 1, the way we learn things is, at least we would probably say, if we didn't, get all confused by some philosopher, the first thing we'd say is that, well, we learn by experience, correct? And how are those experiences mediated to us? I mean, they're mediated through eyes, ears, touch, through senses. And those senses are usually on the periphery, although sometimes we have hunger pangs, so those are internal sensations that we pick up. But usually the senses are out there in the periphery, like there are messages, light signals are being translated, someone might say, at the retina into electrochemical signals which are being sent up the optic nerve, and finally they get to the brain somewhere, and other things happen in the visual cortex. Similarly with the ears, similarly with the fingers, all of these contacts with the world that give us all of our information about it, even contacts with our interior, like whether we're hungry or not. These are mediated by, let's say, neurons, just to make it simple. And it's a little complex. I mean, it's not just like we're sitting there and absorbing passively information. Information comes to us through going up what they call the afferent neurons, and then we actually do some exploring. We often check things, we look behind them, we move around, we grasp them, we do all kinds of things. We are active participants, but that too, I mean, the extent to which we reach out and grab something, touch it, feel it, look around the backside of it. I mean, all of those movements, those muscular movements that are required in exploring the world, they too are mediated by what they call the efferent neurons. And so there's this feedback. But it's neurons that brings information to us. Now, consider a technology, probably not that far in the future, but let's just to be on the safe side, let's put it like 100 or 200 years in the future. Imagine that they've worked out the details of neurophysiology so well that they could take a human brain and, as long as they nourish it, let's say they put the brain in a vat of nutrients so that the brain is flourishing in there. I mean, in principle, they could hook up all the neurons that lead to and away from the brain, hook them up to a big computer, right? And then, like in far too many movies, they can program this computer so that it could make you think that, you're having a real experience. Now, I'm not sure that it would be worth it. It sounds like it might be a very expensive technology, but if it's possible in principle to do that, in other words, to completely be programmed into thinking that, for example, you're sitting in a classroom listening to a discussion of a brain in a vat. I mean, you might be a brain in a vat, right? I might be a brain in a vat. Here I am thinking that I'm talking to a bunch of people, but I might very well be just a brain in a vat of nutrients hooked up to a computer that some perverse scientist is programmed to make me think I'm talking, to a bunch of students. And you poor slobs, you're sitting there, you're programmed, you're not even active, you have to listen to me. So you're programmed with this other experience. But, I mean, it's possible, right? It's possible. Not likely, again, but possible. Now, that's the same kind of story that Descartes is trying to conjure up in different terms when he imagines the evil genius. And the whole point of it is to say, well, for purposes of science anyway, I can't really use the evidence of my senses, at least not all by themselves, as a foundation. Why? Well, because they could be mistaken. It might be that I'm hallucinating. It might be that I'm dreaming. It might be that there's an evil genius who's taken it on as his project to fool me about everything. Or in my story, it might be that I'm a brain in a vat, and I'm just thinking, that I'm looking at a hand in front of my face or talking to a bunch of people. So the whole idea is to establish which things he can be absolutely certain of, and devices like considering hallucinations and devices like the evil genius are his way of really pressing the issue to the wall. Even on the things that you'd think you could be sure of, he wants to say, well, no, not absolutely sure, and so therefore we can't use them as the foundations for science. We're looking for something that's rock hard. Now, maybe there's nothing like that, right? Maybe we'll never find anything like that, in which case Socrates' claim about knowledge would be about the only thing that would be safe, that we can know that we can never really know anything. But Descartes believes he can establish something a little bit more. And that's what we're going to consider here. And that's what he makes a beginning of in the cogito, in the argument that famously has as its conclusion, or at least, Descartes doesn't exactly put it this way, but he's known for having demonstrated his own existence through the argument called the cogito. That's the name of the argument that ends up cogito ergo sum, or I think, therefore I am. And surprisingly, having discussed the evil genius, we almost have the proof before us already. How does he get from this situation of radical doubt to a conclusion that at least something exists? And by the way, this should surprise you every bit as much. This is just an aside, but that he could, on a basis like this, it seems to me it should surprise you every bit as much that he can prove his own existence as that Anselm can prove God's existence from similarly almost empty propositions. It should be a surprise. And that's, one of the parts of the cogito that has made it an object of philosophical interest for these many years, because it's weird if you prove the real, genuine existence of something just from logical considerations, which is more or less how this goes. Now, maybe these proofs work, and maybe they don't. But my job, I think, is to present them to you in such a way as to sort of show you why they're puzzling and why they're interesting. Anyone want to try their hand at this, from having looked at the meditations, or maybe having just considered the argument? How does he go from this sort of all-embracing attempt to doubt anything that is dubious to actually discovering something that, of course, that at least Descartes claims is not doubtable, not dubious, something certain? Well, let's return to the evil genius. We're going to do this 3 different ways. I've got a brain in the vat way, and an evil genius way, and then just a more abstract and general way. But Descartes' position is this. He says, let's say that there is this evil genius. Just, because this is like the worst case scenario, right? Let's just consider the worst case scenario, that there's an evil genius sitting out there. Well, not what's out there, but it exists anyway. And the sole function of this evil genius is to fool me. I mean, everything that I believe, I'm trying to imagine, everything I believe is mistaken because this evil genius has caused me to believe it. Well, Descartes says, well, there's one thing, though, even if that were the case, there's one thing I couldn't be mistaken about. I couldn't be mistaken about my own existence, as you gather from the proofs that that's going to be the conclusion. But why not? Well, because even if there were some evil genius deceiving me about every other thing, I at least have to be in order to be deceived. I mean, the very hypothesis that there's an evil genius out there deceiving me about everything requires my existence as the target of this great effort. Similarly, the brain in the vat story. I mean, even if it were all true, even if this worst case scenario where I'm nothing but a brain in the vat and none of the things that I think about the external world or about my internal state, like I'm programmed, the program says, gets hunger pangs, gets all the signals that you would normally get from walking to the cafeteria, gets all the sensations he would normally get. We will process all of the signals his brain is sending out to make his muscles move, and we will then send back all the signals he would usually receive that will make him think that indeed his muscles are moving. In other words, we do all this stuff. He do all the things that the brain would record and respond to in the line over there, choosing what to buy. I mean, just make the illusion perfect. I may be wrong about all those things. Might be all deceit. Might be just a brain in a vat. But at least I got to be the brain in the vat, right? I got to exist as the thing being deceived. And that's the logic of this. So let's see. We'll start with this step. Let's imagine he's going to try out this. His strategy is to try out the hypothesis that everything can be doubted. In that case, there would be no reliable foundation for science. So he starts off with that proposition. Then takes a particular instance. I mean, this is not going to have to do not any brains in vats or evil geniuses, but he's going to try saying this: I doubt that I doubt, or that I am doubting. I mean, that's just, if everything is doubtable, then he should be able to doubt that. But as you might notice, there's some kind of funniness going on here. Maybe it's even a straightforward contradiction, but at least some kind of funniness, because in doing this thing, I mean, in the thing that's asserted at the beginning of the proposition, I mean, that's the very thing you're trying to doubt. There's a sort of a funny sense in which you're in trying to accomplish this and trying to doubt that doubting is going on, you're undermining the undertaking, right? Now that seems something like a contradiction. It's something like what licenses us to negate this. If everything can be doubted, then it would follow that I should be able to doubt this, because this is just something. But I can't do that. I mean, that's the next step. I can't doubt that I doubt. And doubting for Descartes is just one species of thinking. And so that's where we get to the I think, therefore I am. This might just as well have been called the dubito ergo sum, because it depends so much on the method of doubt. But he thinks that, any time that thinking is going on, then there is a thinking thing. I mean, that establishes the existence of the thinking thing, or at least of the thinking. Not while he's asleep, no other time. And he doesn't necessarily exist as this being here with the arms and legs and stuff. He doesn't know what kind of a being he is, but he thinks he's established his own existence from the fact that thinking is going on. Can't doubt that thinking is going on. Once again, for the same reason. I mean, this is just a slightly more broad way of saying the same basic thing. Because in trying to doubt that thinking is going on, I thereby think, right? I thereby do a kind of thinking. This, he thinks, establishes existence as at least that which thinks. So he believes that he's established here one thing that he can be absolutely certain of. Now that's not going to get us very far towards quantum mechanics, and you'll remember that his project is to establish some kind of a basis for science. So we're going to have to explain how this is going to help in that project. But it's at least momentous if he in fact has succeeded in proving the existence of something from such abstract consideration. And I mean, it may come as a surprise that he can prove anything at all, unless it's like a truism, a tautology. Brian.
I'm still skeptical about it because we could be like, I mean, I'm more apt to believe something you said, and if some alien being walked in here,
Speaking English, of course.
Right. So there could be some other life form, how you say, well, like, the thing I'm skeptical about is if we even think or not, because they could think, well, let's say we want to rule this universe, we're going to make up this species, and we're going to put certain people who can direct others, and we're going to put them in their same form because we can relate to them, so they'll believe what they say, and then let them be skeptical about their own existence, just to make it look more real.
Okay, so I didn't follow the whole thing. Am I the alien now for a minute? Let's say I'm the alien? No.
You're still one of us.
Who might be, let's say an alien comes in here, but they're going to look like us, right?
Sure.
And then what are they going to do? They're going to start offering
No.
skeptical arguments?
An alien, we don't have to see, there's another form that's somewhere out there, we don't even know they exist.
Uh-huh.
But they want to make some other form, which is us. They've found a DNA to make it, or whatever they found.
Uh-huh.
Chemicals they need to make us up, but in order for us to do what they want, they need a way to communicate with us. And they can't just go to each person. They'll make someone like you up to teach us something. But you won't say it in a form as, oh, there's this life that we have to live like. There's this other life form out there. You're going to say, in a classroom-like thing, it's just going to become something that's known.
So am I getting this right? Then my own impressions that lead me to think that I'm thinking are like little radio signals from these guys.
It's almost like a computer. I mean, all the input we do in a computer's not thinking. We're just putting stuff in there.
But all right, and that's an extraordinary. That's one of the reasons why this is this sort of thought experiment is useful in modern cognitive science and artificial intelligence and stuff like that, where people are trying to figure out, well, what is thinking? Or how can we mimic it? Or what's the limits of our abilities to mimic thinking? And you might ask a question that sometimes comes up in Star Trek, by the way, but you might ask, like, let's say you had a perfect machine, like Data, or a near perfect machine. Would it think it was thinking? I mean, it's designed in such a way as to make all the rest of us think that it's thinking. It functions just like all the rest of us do, as far as we can tell. But what about it? That's a real good question. I don't know. And it's a question that comes up very interestingly and is treated very, very well in some Star Trek episodes. I mean, Data doesn't know. I mean, he's got nothing to compare it to. I don't know. He doesn't know what we do and what we feel like any more than we know what he feels like. So he can only guess and surmise. And so it's left an open question. But on the question of existence now, I think it's reasonable to wonder about whether, what the character of anybody else's thought is, and maybe even try and figure out, well, what is this thing I call thinking? But on the question of existence, if I'm the automaton who thinks he's thinking, I'm actually just a robot of some sort, controlled by aliens. Don't I nevertheless at least have to be, well, whatever it is that, I mean, this presumes my existence as much as anything else does. And I do call it thinking. I may be wrong about the character of the thinking, and this is important. It's not just that I might be wrong about whether I have a body. We'll concede that. I mean, don't think so, but we'll concede that. But as Brian points out, I might be wrong about just what the thinking that I'm doing really is. It might not be autonomous, for example. It might be controlled from outside. That's a possibility. But it's still going on. And if it's going on, I've got to exist for it to go on. At least that's the kind of reasoning Descartes is using here.
Well, I wouldn't say that you're doing, no matter what kind of thinking it is, because it's coming from this other alien or whatever, they're doing the thinking.
But I am that which is
Okay.
being controlled, okay? And I must exist to be controlled in this way. And while I may be dead wrong about whether it's my thinking, or that it isn't in a way, it's my controlled thinking. I mean, I'm doing something there. But all that Descartes needs is to leverage, all he thinks he needs to leverage himself into this existence claim and proving that something exists, namely him, is that even if he's being controlled by aliens, he has to exist to be controlled by aliens. Okay?
I was wondering if we could briefly reverse the situation, and if we know that we think, like I know that I exist because I think, but how do I know that anyone else exists?
You don't. That's a very, very good. This leaves Descartes in what appears to be a very solipsistic position. And solipsism is the view that nothing in the world exists except me. That's a philosophical position that is taken seriously by lots of people who really think hard. I mean, if you think hard about the fact that, this brain in the vat possibility, right? And then don't imagine necessarily that it's scientists out there doing anything, but some sort of natural forces that are just, giving you impressions, giving you the sense of sight and making you, and then maybe your mind is active enough, it sort of concocts a story out of all these things to try and just keep you sane, and tries to put all the impressions that you're getting. I mean, if you think very hard about it, sometimes it's very easy to get kind of depressed and think, people are really they're alone, they're inside there, and it's hard, they're not really in touch with the outside world because they got all these neuron things that are the only means of contact, and who knows if the neurons are reporting information correctly. I mean, maybe there's just systematic error all the time. Maybe I'm talking to a room full of elephants, for example. I don't know. But some of that seems quite ludicrous, but lots of folks have at least said this: we can't be sure about anything concerning the external world. And in particular, for lots of reasons, we can't be sure that anybody has experiences like we do. Maybe all of you people are data. You may be all robots. Maybe there's not a single other creature in the universe except me, and then I think each of you are in a similar position, you might say that. But I'm just guessing that you have feelings and thoughts like me because of your external behavior. But you might just be like data, right? You might just all be robots. We are all robots. You got us now. Damn. We were supposed to keep this going till the end of the quarter. Yeah.
I was just, if that is the case, then that just kills what he's trying to do, because if you can be skeptical like that, if we are just robots, then how is he going to prove that there's things in science you can be sure of?
Well, not yet, not yet, but right here, he thinks he's accomplished something important if he can even just produce a proof of his own existence, okay? That's not going to get him very far if that's all he can do. So how is he going to go anywhere from there? Well, his way is sort of characteristic of philosophers. It's not so much the particular conclusion that's important to science. It's that that by some means we were able to establish a conclusion like that. So now the question is, well, what are those means? What is it that gives us the warrant for drawing this conclusion? Whereas, after all, we're prepared to doubt the evidence of the senses. We're prepared to doubt the evidence of our own personal experiences. We're certainly prepared to doubt what other people tell us. But what is it that warrants this conclusion? And I guess the closest thing to a simple answer that I can give is it's logic. And it's the only thing that warrants that. It's the terror of something like a contradiction that comes in there. Contradictions can't be true, or we can't. I'm not sure whether this is a contradiction at all, by the way, but there's something like a practical contradiction. I mean, you can't do it, I guess. That's the claim anyway, is you couldn't do this. You couldn't doubt that doubting was going on at that particular moment, because you're doing it, man. So you can't pull that trick off. But there's something like a contradiction in that problem, whatever the problem is in that line, and that's what seems to give us a license to draw conclusions. And this is this diagnosis that's what's going on here, because Descartes never says that. He never says that the thing that that it's pure logic that gives us a genuine right to draw certain conclusions. He doesn't say it that way. In fact, he says the things that we can rely on are something called clear and distinct ideas. So it's the clarity and distinctness of an idea that's supposed to give us some sort of guarantee. He uses as examples this. But he gives us another one too. Here's another one. It seems to have the same kind of warrant. 2 + 3 = 5. It can't be false. Unless you're changing the meanings of some of these symbols, that has to be true. So while this is his slogan, he says these ideas are clear and distinct, and so that's the warrant that they've got. Now that expression, clear and distinct, isn't very clear and distinct to me. Never has been. It's like, what is that? What's the flesh on those bones? I think it comes down to logically necessary. We can rely on stuff that's logically necessary, that couldn't be false. And the fact that he uses 2 + 3 = 5 is another example of things like that. That's revealing. He is a mathematician, after all, and part of what he's suggesting, I think, is that in our construction of science, we should try to make it mathematically rigorous. We should use mathematical methods for scientific inquiry, which is what, at least it's part of the story of the birth of modern science. I mean, it's Galileo who has offered us a means of understanding projectile motion, the motion of objects that are thrown or shot, cannonballs. Galileo has offered us a mathematical means for understanding projectile motion. Descartes has offered us a mathematical means of expressing geometric truths, because Galileo did all his work on projectile motion in geometry, in constructive geometry, just flopping around those triangles and squares like they did in the Meno when Socrates was talking to the slave boy. But it was using those old geometric techniques. Those are the ones that Galileo used to analyze projectile motion. But Descartes offered a way of expressing those truths in algebra, which sort of simplifies things. And then not too long after Descartes, Isaac Newton invents the calculus, which has as part of its foundations this very analytic geometry that Descartes figured out. And from then on, all of modern science, modern physics in particular, is highly mathematical. And Descartes is giving expression here to that proposal that science cannot be done, if it is to be rigorous, if it is to be reliable, cannot be done just by using the intuitions of people about how things work, can't be done by simply using the evidence of the senses. Think about this postulate that has become so controversial with the church, namely that the sun is in motion across the sky. I mean, that's the old way of saying it. I mean, to say that the earth stands still and just look, the sun looks like it's moving across the sky. So that must be the truth. This new Copernican theory conflicts with the evidence of the senses. The senses tell us the sun is moving. Copernicus' theory says that the sun is stationary. So Copernicus' theory must be wrong. It conflicts with the senses. Well, Descartes saying, we can't rely on the senses for science. We need more rigorous methods than that, and mathematical calculations, those are the sorts of things that we should use. So he doesn't get to quantum mechanics, and he doesn't get to much else, but he does offer us this suggestion that if we're looking for good, solid methods, reliable in the sciences, that we need to stick to rigorous mathematics.
Isn't that contradictory in itself? Isn't mathematics based on sight? I mean, how can you figure out something? I mean, once you've memorized something, then you can say, all right, 2 plus 3 is 5 because I've memorized it. But you have to see it first to understand what you're talking about.
There's controversy about that, but let me offer you, you're suggesting that in order to know that 2 plus 3 equals 5, I need to be able to, you don't really think sight in particular. I mean, blind people can learn this stuff too.
Right.
And they can see the necessity of something like that. It's not just a memorized fact. But you're saying, well, we do have to, we drill the tables, multiplication tables and stuff like that, and so the first steps are always memorization. I think what Descartes would argue, and I agree with him here, that those aren't, that's not exactly the way we learn the truths, the necessity of mathematical truths. Those are drills. They prepare us. They are useful. But in the end, there's this aha. I mean, it's not just that we've memorized this. We see it has to be the case. I mean, if you know what, I think I may have done this before, but if you know what 5 is, and you're using your sight, but if you know what 5 is, and I could define it without a visual illustration, of course, but if you know what 5 is, and if you know what 2 is, and 3, and plus, and equals, then, 5 just is 2 and 3, right? It just is that. It's true by definition. And this has to be communicated to you some way. I mean, it could be shown to you visually, or it could be spoken to you. And you can just memorize that. But there's a difference, and this harks back to stuff we talked about when we were talking about Plato. There's a difference between the way you understand 2 plus 3 equals 5, if it's just memorized, on the one hand, and the way you understand it when you see its necessity. When you see, well, it has to be true, right? I mean, it can't not be true. That's the difference that Plato referred to as the difference between mere true belief or true opinion on the one hand, and knowledge on the other. Now, whether you use those words or not, to see the necessity of something, to see why it has to be true, requires a step beyond mere memorization. So the memorization can kind of give us the materials that we can then use. I mean, we've got to have symbols of some sort. We don't need to use these symbols. We could have chosen our own symbols, invented an entirely different system of symbols, but the mathematical truth behind them would still be the same. Like, this is a little bit difficult to do, but it's not too much mental exercise. Imagine that, for example, in our number system, the numbers 3 and 4 just simply gets swapped. So that now the number series goes 1, 2, 4, 3, 5. And that's the only change I want to recommend for our number system. Well, then this turns out to be false. Right? But that just goes to that shows you, I think. I mean, it's another way of illustrating that the mathematical truth behind this sentence isn't just a matter of memorizing symbols. I mean, there's a truth there that's being reflected, and the symbols don't much matter. There's a logical necessity to whatever it is that we express normally by saying 2 plus 3 equals 5. And in the new system that I just recommended, that would come out then. That would be true. And true by logical necessity. True just because of what they are. Just as bachelors are necessarily unmarried. Just by virtue of the definition of bachelor, the claim here is 5 is necessarily 2 plus 3, just by virtue of what all those things, 2, 3, 5, and plus, what all those things are. Let me say this and then the last word. So the upshot here is that what we get in Descartes is a strong recommendation of what some people might call rationalist, I mean reason, logical methods. In fact, a condemnation, in a way, of experience as a reliable source of information. Now, there's other places where Descartes, of course, has to take this back a little bit. You can't rely on nothing but reason to get anything like a science about the world. So he's not so foolish as, I don't believe he was so foolish as to really think that, but he's suggesting that any certainty we're going to get out of science is going to come from the extent to which we can use logical and mathematical methods, rigorous methods. That's how we can have reliable science. Any departure from methods like those will be a departure into the less well-known, the less certain. So I think that's the method here. And what we'll see when we get round to talking about Locke is the other side of the scientific coin, namely the importance of empirical evidence. The importance of, I mean, you can't not have that either. And in Locke, we'll have a thesis that suggests something like what Brian was suggesting is, this is nonsense, an empiricist would say, and Locke will say. There is no other way to get knowledge except through experience. There is no other way to do that. And in making that claim, the empiricists, people like John Locke and David Hume, whom we discussed, they part company not only from Descartes, but from a tradition that goes back at least to Plato.